Yes, hello students. We are meeting today in lecture number 10. I welcome you all to this lecture number 10 of linear differential equations with constant coefficients. Before this lecture number 10, we did up to lecture number 9. We have discussed different cases of this when we have linear differential equation with constant coefficients of f dy is equal to x. You know, we took different cases of x. When x was 0, then we have only one solution, that is a complementary part is the solution of this when x is 0. When x takes different forms, such as exponential form, trigonometric form, and so forth. And now we have the case here. We discuss actually this is case fourth, perhaps case fourth we are discussing here. Case first was exponential, then it may be case I will not name this case, it may be third or fourth. It is the case when I will write when x is equal to some algebraic expression in x, because independent variable is here x, so we say it is some algebraic expression in x. Say your x can be of this form. Sometimes right side x is say x square, say it is x plus 1, say is x cube plus 1. It can be x square plus x minus 1, so on. You will come across now right hand side of this form. The complementary function part is same in all the cases, whether x is an exponential part, whether x is this trigonometric, whether x is this algebraic expression. The complementary part you find the similar way that you did in previous cases. Now I want to discuss here how to find out particular integral in case x is of above forms. When x takes the above forms means this algebraic expression, how we proceed to find out the what is called the particular integral. You see what we do is, we have as usual our particular integral is as usual 1 by f of d, the function of d that involves after writing the linear differential equation in it is what is called this symbolic operator representation. Then you have here x. We this note here some steps. What we do is step number one is we take common from denominator, that is from function of fd, the lowest degree term. It will contain some lowest power of d raised power 0. When it has constant, take that constant out. If lowest power is of d is d raised power 1, take that d out. Then you why we do take it common, it will take this form. Then denominator of particular integral will take the form, 1 plus some function of d. It will now change, it will not remain fd, it will remain some function of d. When you took the lowest degree term common, naturally you get 1. Our aim is to have 1 first in the denominator, and when it has the expression, it is the expression in d, right, to have denominator 1. For that we take the lowest degree term common, or it can take the form this 1 minus some function of d. It can take this form. Then step number second is we bring we bring, I will assume here when x is of this form, I will write here assuming x is x raised power m, where m is some positive integer. I am assuming that our x is here algebraic expression. We assume here that our x is x raised power m, say x cube, x square, something like that, where m is some positive integer. Okay. Now we bring, after this we bring 1 plus psi of d, or if it is 1 minus psi of d in the numerator. When you take this 1 plus psi d from denominator in the numerator, naturally it will have power minus 1. If it is this form, it will be in the numerator minus 1, this will be minus 1. Then expand it, we expand it by binomial theorem. We apply binomial theorem. Well, we applying binomial. If it is not visible here, I will write here expanding by binomial theorem containing term up to d raised to power m. I will expand it up to d raised to power m. I will omit d raised power m plus 1, d raised power m plus 2. The reason is simple. Suppose if my capital X is here, x raised to power 3. Remember, if I write d of x cube, what is that? Differentiation. It is 3x square. When I write d2 of x cube, it is 6x. When I write d3 of x cube, what is that? It is 6. When I write d4 of x cube, what is that? It is 0. So I need these terms. So that is why in case of x cube, when x raised power 3 is here, your m is here 3. Your m is 3. When we took capital X raised power, your m is 3. When I have to expand 1 plus psi d raised power minus 1 or 1 minus psi d raised power minus 1 by using binomial theorem, up to what terms I will go, because it will contain infinite number of terms. When we expand it by binomial theorem, I will stop it up to d raised to power m. Here I will stop it up to d raised cube, d raised power 3, because derivative of d raised power 3 is 6 constant. Then after constant it becomes 0. You will come to know when we take the questions application part. You will see how we do. So we expand it up to terms containing d raised to power m. Well, now while using the binomial theorem, you will remember two important results of binomial theorem. We apply these two results of binomial theorem. You will remember them. We apply frequently, I will write. We apply frequently these two results of binomial expansion. Well, one is 1 plus d raised power minus 1. That means if it is 1 plus psi of d, these are psi of d, function of d, it is equal to 1 minus d plus d square minus d cube plus dash dash so on to infinity. we will use this thing. If it is like this, 1 minus d raised power minus 1, that is 1 minus psi of d, we will use the formula all positive. 1 plus d square plus d cube plus d4, here then it will be a d4 minus 1, d4 plus 1 to infinity. We use these results. I will write here, you will remember these results, so that you will save time. If you apply the binomial theorem, 1 plus x raised power n is 1 plus nx, then plus n into n minus 1 by 2 factorial x square plus n into n minus 1 n minus 2 by 3 factorial x cube, so on. You don't need to write those steps. You use, this is binomial. If you expand this, you will get it. This is binomial. This is not other than binomial. This is the binomial expansion. When you apply binomial theorem, this you will get this thing. So remember this. This is very simple to remember. When you have this positive, this negative, signs are alternate. When this is negative, all signs are here positive. It is less like d0, d raised power 1, d raised power 2, d raised power 3, so on. Remember this. We will be using these results when we use this solve the linear differential equations of the type when right side is some expression of independent variable. When it is an expression involving x, x square, x cube, so on. Let me have some I have written here some application for your this reference. These are some applications here. I will rub it. You see how we go. Suppose I have this here to solve. Number 1 question is here to solve the differential equation. It is in the symbolic representation d cube minus 5d square plus 6d y. You see right side is your x square. It is an algebraic expression. Now you write here for complementary function, you write auxiliary equation. Auxiliary equation is same way as you do. Auxiliary equation will be d cube minus 5d square plus 6d is equal to 0. You don't have any constant here. You can take d common here. Taking d common, it is d square minus 5d plus 6 equal to 0. This gives you either d is 0 or it gives d square minus 5d plus 6 is 0. If you solve this d, what is the d here? D is 5 plus minus under root of 25 minus 24 by 2. It is d is equal to 5 plus minus 1 by 2. So d is 5 plus 5 minus 1, 4 by 2, it is 2. It is 5 minus 1, it is 3. So your d is here. This gives d 2 comma 3. So therefore d is 0, 2, 3. You get real values of d. So what is the complementary function corresponding to this? Complementary function is c1 e raised to power 0x plus c2 e raised to power 2x plus c3 e raised to power 3x. So this means that my complementary function will be here. Complementary function I get. Complementary function is, it is c1 plus c2 e raised to power 2x plus c3 e raised to power 3x. This is the complementary function. Now I go to find out particular integral. Look here. What is the particular integral in this case? It is very important. This thing we want to learn in this case, whether it is third or fourth case. It is a case of this when this is right side is expression in x. Okay, this is x square by d cube minus 5d square plus 6d. Be cautious here. X square by d cube minus 5d square plus 6d. F of d is this. Now you have to see what is the lowest degree term here. If it is constant only 6, then you have to take 6 common. Here the lowest degree is this 6d, lowest one. Take this 6d out, 6d. This will be your x square. Try to learn here how we go. When you take 6d common, this is d cube minus 5d square by 6d plus 1. I want to have here 1. That is why we take the lowest degree term common, taking 6d common. So when you take 6d, you are getting dividing by this 6d. Well, this will be here. This will be x square by 6d. If we divide by this d, taking d common, it is d square minus 5d, d square minus 5d by 6 plus 1. This is your psi of d. This is actually now x square by 6d is out. It is 1 plus d square minus 5d by 6. This is your 1 plus psi of d. This is now function of d. Here I have to use the binomial theorem. You see how we go. I will drop it. We will go in the above part. I will take here complementary function as it is. We require it. Well, we are finding out particular integral. My particular integral is here. My particular integral will be, it is 1 by 6d. I will write here 1 by 6d. Then it is 1 plus d square minus 5d by 6 raised power minus 1 into x square. Be cautious. I took it in the numerator now when it was denominator. When you take it in the numerator, this fraction, this becomes minus 1. Now you have to use this one here. Suppose you have 1 plus d dash raised power minus 1. What is this? 1 minus d dash plus d dash square minus d dash cube, so on. Binomial theorem. Using binomial theorem, using binomial expansion, you may say, this is your 1 by 6d is out. Now you have to see up to how many terms I have to expand it, containing square, because it is here square, up to square I will go. It is 1 minus, what is your function of d? D square minus 5d by 6. It is 1 minus d. Your d is this. Remember, 1 plus d. Then plus d square, then plus d square minus 5d by 6 whole square, plus so on. I will omit the other terms here. I don't write q because we don't read here. It is, if it would be 3 here, then I have to write that another term which would be minus d square minus 5d by 6 whole cube. I don't require it because power is 2 here. Now I will expand this one. This is 1 by 6d. You see what is this? 1 minus, it is d square minus 5d by 6. This will be your plus d4. This is plus 25 d square. It is minus 10 d cube by 36. Other terms I will omit. It will have other terms, but we omit that. We don't require that. I have given you the reason. The reason will again come to you. Why? You see here, what we do is, just look here, very important. When you write d of x square, what does that mean? You are writing derivative of x square with respect to x. It is 2x. When you write d2 of x square, what is that? It is 2. Derivative, second derivative of this. When you write d cube of x square, what is that? It is 0. So from this I will omit d cube and it is higher powers. I don't require them because their third derivative of x square is 0. So I can write here omit or neglect, or you can say neglect d cube and higher powers. I don't need them. I don't need d cube, I don't need d raised power 4, I don't need, so I will omit this one. I don't need to require this, I don't need this. The reason is this. Do you follow? It is 1 by 6d. This is 1 minus d square minus 5d by 6. So from this I get only 25 d square by 36. And operating upon x square we have to operate. Now let me simplify this first. You look here. This is the complementary function. I need it. just see what I, this is your particular integral is 1 by 6d. This is 1 minus d square minus 5d by, or you write it is 6 minus d square plus 5d. I take 6 LCM, minus goes inside, 6 minus d square plus 5d by 6 plus 25 by 36 d square x square. Now you can operate by x square like this. You can write this 1 by 6d in this way. It is, take this x square, it is 6x square minus d2 of x square, then plus 5d of x, 5d of x by this 6, then plus 25 by 36 d2 of x square. It is x square here, d of x square. I will just see, it is 6x square, d2 of this x square, 5d of x square by 6 to 35 by this. Now you know what is d of x square to x. What is d2 of x square? It is 2. You have seen here. Just look, it is 1 by 6d, it is 6x square minus d2 of x square means simply 2 plus 5 d of x square means 2x, it is by 6. Here plus 25 by 36, what is d2 of x square? D of x square means 2x, it is d2 means 2. So what you get? It is 1 by 6d, it is 6x square plus 10x minus 2 by 6 plus 25 by 18. How you go now? You can, it is a very important because we have 1 by d. If there would not be 1 by d, our particular integral was complete. It is not yet complete because of the occurrence of 1 by d. 1 by d means reciprocal of the derivative, it is integral. You see how we go in here. Just look, particular integral, my 1 by 6 is thrown out. Then I write 1 by d of 6x square, then plus 1 by d of 6x square, or you can write by 6. I am splitting here, 6x square by 6, 10 by 6, 2 by 6. Okay, it is plus 1 by d of 10x by 6, be cautious, minus 1 by d of 2 by 6, it goes, then plus 25 by 18, it is 1 by d, or simply you can write 1 by d of 25 by 18. Now how it goes? Just look now, it is particular integral here 1 by 6 throughout, it is 6 goes, 1 by d means integral of x square dx, then plus it is 10 by 6 which means 5 by 3, 2 5s are 10, 2 3s are 6, 5 by 3, 1 by d of means x dx. Okay, this is minus, this is 1 by d, it is 2 by 6, 1 by 3 of integral 1 dx constant, it is plus 25 by 18, it is 1 of dx, because it is constant out, integral 1 by d means integral, it is 1 by d here. Well, it is particular integral is 1 by 6 throughout, integral it is x cube by 3, integral of this it is plus 5 x square by 3 into 2, then it is minus 1 by 3x plus 25 by 18x. You have to only simplify this now. So particular integral is 1 by 6, this is x cube by 3 plus 5x square by 6 minus x by 3 plus 25 by 18x. Okay, you can take here, you can take throughout 3 common, you can take 3 common, take 3 outside, it is 1 by 18 here. To avoid the further simplification, 3 6 18, it is x cube, it is 5 by 2x square, it is plus, it is minus x, then it is 25 by, when you take 3, 6x. Well, this will be 1 by 18 x cube plus 5 by 2 x square. You combine these two. How you combine it? It is minus 6 plus 25 by 6x. That will be 19x. It is x square, that will be plus 19 by 6x. Okay, this is your particular integral. So what is the complete solution now? It is complete solution is y is equal to complementary function plus particular integral. So it is y is equal to your complementary function is c1 plus c2 e raised power 2x plus c3 e raised power 3x. Particular integral is 1 by 18. This is x cube, it is 5 by 2x square, then it is plus 19 by 6x. This is your particular integral, this complete solution. This is how we go when we have the right hand side, the function of this x, or the expression involving x, polynomial in x. Well, dear students, let me take one more application so that you are in a position to do other parts from your book. It is 2 question. You have to solve the differential equation y double dash minus y dash minus 2y is equal to x square plus cos x. It contains 2 parts, right side. Right side contains, one is algebraic part and second is what? This trigonometric part. Now it is symbolic representation is it will be d square minus d minus 2y is equal to x square plus cos x, because your y dash is dy by dx and your y double dash is d2y by dx square. Here you can do. Now I leave this to you. Find complementary function. You will find complementary function here. That is why I have mentioned here it is answer. So we did this question. I have mentioned it is answer. You can do it here. Let me show you how to find out particular integral. Particular integral is, you can find out complementary function now. Particular integral will be, this is your x square plus cos x by d square minus d minus 2. It contains 2 parts. We can write this way. This is x square by d square minus d minus 2, then plus cos x by d square minus d minus 2. Well, this is particular integral is, I will name this I1, I will name this I2. I will find out I1 and I2 now directly, separately I mean. First I will go for I1. How we find out I1? One part of the particular integral. Well, my I1 is here x square by, it is x square by, second is cos x, it is x square by d square minus d minus 2. D square minus d minus 2. Here the lowest degree term is here 2. You can take 2 common like this. X square constant you take common. It is constant common. It is d square minus d by 2, then minus 1. Okay. If you want to write it in the form of 1 plus d or 1 minus d, you can do it. You can write this way also. It is x square, take minus common, minus 2. This is now, this will become positive 1 minus, this is negative d square minus d plus 2. No problem. You can go this way also. Because I have already told you, when we take the lowest degree power in d, lowest degree term common, we want to have the denominator 1 plus psi of d, function of d, or 1 minus psi of d. It was here minus 1, I took minus common, so I write it 1 minus d form, d minus d square minus d by 2. Well, this is your I1 now. Minus 1 by 2 out, take it in the numerator, it is 1 minus d square minus d by 2, it is raised power minus 1, outside it is x square. Algebraic. Well, using the binomial, I have to expand it up to terms containing square terms. It is I1, it is minus 1 by 2, expand it, negative, negative, all are positive, then 1 plus d square minus d plus 2 minus d by 2, then plus d square minus d by 2 square, plus so on. I will stop here. I don't need d raised power 3, I don't need d raised power 4, so on. Well, this is I1 minus 1 by 2, it is 1 plus d square minus d by 2, this will be plus d4 plus d square minus 2d cube. When I open it, it is 4, 2 to the 4, this is your x square. Now you have to omit or delete, omit d cube and d4, because I don't, and d4, I don't require them. The reason is known to you, so I write it now. Your I1 is minus 1 by 2, this is 1 plus d2 minus d by 2, I will omit d4, I will omit d cube here, it is only d2 by 4. Okay, because d cube of x square is, third derivative of x square 0, fourth is naturally 0, so I need only these two. Well, simplify this now. This is I1 is minus 1 by 2, I will write it now, 1 plus d square by 2 minus d by 2 plus d4 by, sorry, d square by 4 x square. This is your equal to minus 1 by 2, it is x square plus 1 by 2 d2 of x square, taking x square from right, minus 1 by 2 d of x square, then plus 1 by 4 d2 of x square. d2 of x square means second order derivative of x square, d of x square means first derivative of x square. It is I1, one part of the particular integral I am finding out, minus 1 by 2, this is x square. Now when you derivative find, it is square here, d of x square is 2x, it is so simply 2, it is 2 by 2, minus 1 by 2, it is 2x, and this is your d2 of 2 by 4. And this I1 comes out to be minus 1 by 2, x square minus x, then 1 by 2 plus 1, it is plus 3 by 2. When I connect this and this, 1 plus 1 by 2, it is 3 by 2 simply. This gives me one part of the particular integral. I will go for second part. I will write it here, I require it. I1 I have got minus 1 by 2 x square minus x plus 3 by 2. Now let me go to find out other part जिसका मैंने नाम दिया था I2 से. Your I2 is what? It is cos x by d square minus d plus 2. Now remember, just remember when we find out particular integral for cos ax, by f of d square. We replace here, it is cos ax by f of d square is replaced by coefficient of x in the angle, that is a, minus alag, a square alag. D square is replaced by a square but minus outside. It is provided f of minus a square is not 0. If it is 0, then you know the rule. We apply this failure rule, that is derivative rule. You have with this. Now here coefficient of x is here in the angle 1. You write it is cos of x, then minus 1 square minus d as it is plus 2, because we have to use it for d square. So this is your cos x by, it will be plus 2 minus 1. It is 1 minus d. Now what to do, because I have the linear factor in the new denominator, linear, for the linear to bring it quadratic here, d square, I apply rationalization. As you know, I write 1 plus d here, 1 plus d. Why I am doing this? To have in the denominator d square. That is why I am rationalizing. It is the previous part that you did. It is d of, it will be now cos of x into 1 plus d. This will come 1 minus d square. Then next replace d square by minus 1 square. This will be well, this will be your cos of x into 1 plus d. This is 1 minus 1 square, because coefficient of x is 1. We have to replace d square by minus 1 square. So I2 comes out to be, this is minus plus 1 by 2 cos of x into 1 plus d. Now operate this cos x. It is 1 by 2 cos x plus d of cos x. So I2 I have got, it is 1 by 2 cos x. Derivative of cos x is minus sin x. It is minus sin x. Well, you have this our particular integral is, what was this, I1 plus I2. You use it here and you will get this I2 1 by 2 cos x plus sin x. This was for x square plus cos x, when it is d square minus this d plus this. You just look, we may have, because he says he gives answer something different, we may have committed a mistake. I will clear the mistake here in simple way. I will clear the mistake here, because he says in the answer this part is okay, but this part he says something different. I will write it quickly for your clarification. This is cos x by, it was d square minus d minus 2. Just look, it is cos x by minus 1 square minus d minus 2. It is cos x by minus d minus 3. It is cos x by minus common d plus 3. Perhaps we have committed a mistake here. I have forgotten to write this minus 2. It is minus 2 here. I wrote there plus 2. Clear it, please. Clear it. This step I have this reproduce this step. Reproduce the setup. You reproduce this setup. Then you write rationalization. It is d minus 3 by d minus 3 here. This will be your minus out. This is cos x by d square minus 9. Then it is d minus 3. It is okay now. This will be, when you write it, minus 1 square, that is minus 10 plus 1 by 10. It is here 1 by 10. Then d of cos x minus 3 cos x. Then d of cos x is minus sign. It is minus 1 by 10 sin x plus 3 cos x. This is I2. This is your I2. I am reproducing this because we committed a simple mistake here. Instead of writing d square minus d minus 2, I wrote there d square minus d plus 1. That is why I have got I2 different. So this is your correct I2. This is your I2. Replace this I2 here. I1 is okay. Then you will write the complete solution is y equal to complementary function plus particular integral. This will be your this part. Okay. Let me have third one. It is d square minus 5d plus 6 into y is x plus e raised power mx. I leave one part to you. I will write here find complementary function. For that, your auxiliary equation is d square minus 5d plus 6. It is d is 3 and 2, and you can do it. Now when you go the particular integral, you see how we find out it is particular integral. It is x plus e raised power mx by d square minus 5d plus 6. It has two parts now. One is x by d square plus minus 5d plus 6, then plus e raised to power mx by d square minus 5d plus 6. This you can write particular integral. This is your algebraic part here, linear. It is x by, in the denominator you see what is the lowest degree term, that is 6 constant. Take constant out, it is out. You have this d square minus 5d by 6 plus 1. Very simple it is. Then plus it is this part. How you do exponential part? You replace the this coefficient of x in the exponent by d. This if it is defined here, it is x, the coefficient of x is m. I replace this here. It is e raised power mx. It is first case. It is m square minus 5m plus 6, replacing d by m by first rule. It is defined here. So this second part is okay. E raised power mx by m square minus 5m. We have to evaluate this part. How we go? It is particular integral is 1 by 6 is out. Take it in the numerator. It is 1 plus d square minus 5d by 6 raised power minus 1 into x, then plus e raised to power mx by m square minus 5m plus 6. Look, you have to expand it. Up to how many terms you will go? You will go second, 1 plus d only, because it is x raised power 1. This is 1 by 6. What is your this? This is negative positive. It is 1 minus d square minus 5d plus 6. No need of writing other terms because we have the power of x here 1. So I write here d power 1. Other term second, if I write, that will be d square minus 5d by 6 whole square. That I don't need. Then plus e raised to power mx by m square minus 5m plus 6. Okay. Well, dear students, you have particular integral here. It is 1 by 6. Take x here. It is x minus 1 by 6. It is d2 minus 5d by d, because I took 1 by 6 here. D square minus 5d into x only. Then plus e raised to power mx by m square minus 5m plus 6. Now this is 1, yes, I took x here. This is 1 by 6, x minus 1 by 6. One is, what is d2 of x, d2 second derivative is 0 minus, what is df? It is 5. It is plus e raised to power mx by m square minus 5m plus 6. Therefore you are getting here particular integral. It is 1 by 6. It is x minus 1, it is plus 5 by 6, x plus 5 by 6. This is plus e raised to power mx by m square minus 5m plus 6. This is your particular integral. Complementary function you can find out easily. Then add y is equal to complementary function plus particular integral. This way you did this also. Now you look, if you have to find out the I will show only particular integral for this question also. You see here, if you want to solve, suppose you have to solve d square plus 4y is equal to x square. You find complementary function because your auxiliary equation is here. D square plus 4 is equal to 0. It is d square minus 4. That is d is equal to plus minus 2 iota. It is d is equal to 0 plus minus 2 iota. You can write complementary function e raised power 0x into c1 cos of 2x plus c2 sine of 2x. Where does this 2 comes? Coefficient of iota in the complex number. You know it. What is this 0? This is real part. It is e raised power 0, that is 1. Then particular integral you will go this way, x square by d square plus 4. Well, here the linear, this lowest degree term is 4. It is x square by, I will take 4 common. It is 1 plus d square by 4. Then you write particular integral is 1 by 4 out. It is 1 plus d square by 4 raised power minus 1 into x square. I have to open it. 1 by 4. It is 1 minus d square by 4. That is 1 minus d. This is your d. Then plus square d square by 4 whole square plus so on. I don't need here higher powers, d cube, d square, d cube, so on. So this is 1 by 4. It is 1 minus d square by 4 only plus 0 into x square, because d2 of x square means 2 and d cube of x square means 0. I don't need d cube and d4. So this is your 1 by 4. It is x square minus 1 by 4. What is second derivative of x square? It is 2. So particular integral is 1 by 4 x square minus 1 by 2. This is the particular integral. It is particular integral. Suppose you have one more part. Well, you want to solve this part. Solve d square plus 2y is equal to x. This is x square plus 1 whole square. This is x square plus 1 whole square. Or it can be, it is perhaps x plus 1. As per the answer, it can be, yes, x plus 1. You will find out complementary function. You go for particular integral. It is your x plus 1 square by d square plus 2. This is your x square plus 2x plus 2 plus 1, sorry, x square plus 2x plus a square plus 2ab plus b square, by taking 2 out, 1 plus d square by 2. Well, this is particular integral as 1 by 2. This will be 1 plus d square by 2 raised power minus 1 into x square plus 2x plus 1. Well, you open this. It is 1 by 2. It is 1 minus d square by 2 plus d square by 2 whole square. I need here 2 terms plus so on. It is x square plus 2x plus 1. Just see here, what is d of x square plus 2x plus 1? It is simply 2x plus 2. What is d2 of x square plus 2x plus 1? It is 2. What is d cube of this? It is 0. I don't need d cube and d4. So I need here particular integral will be 1 by 2, 1 minus d square by 2 only into x square plus 2x plus 1. Why so? Because it is here d4. I don't need d4. I omit it here. Now take it inside here. It is 1 by 2. Multiply this factor with this one. It is x square plus 2x plus 1. Then minus 1 by 2 d2 of x square plus 2x plus 1. This is your 1 by 2 out. X square plus 2x plus 1 minus 1 by 2. What is d2 of x? I have found out, it is 2 simply. So this is your 1 by 2, it is plus 1, this will be minus 1, it is simply x square plus 2x. So your particular integral is 1 by 2 x square plus 2x. This is your particular integral. Okay, this was the case when you have x plus 1 whole square. You see, we open it, then because highest power is here x square, so we need to expand this up to third term only. This is your square up to third term only, but when I reach to third term, it contains d4 here. I omit d4 also, then I am getting this thing. So particular integral is 1 by 2 times x square plus 2x. I hope you have understood how to deal with the questions when we have right side the function of x or the expression in independent variable, which is x, when we have dy by dx. There you have to use the binomial theorem. Then I will come with another this case. Till then you wait. Thank you very much. I see you next. Till then, goodbye. Allahu Akbar, Allahu Akbar.